Okay, so there we go. So there's the question. So investment company, 9%. You want 12,000 in the future, so same formula. A equals P, 1 plus R over N to the NT, like that. And let me, you probably already know what to do. Let me give you just a second, in case you haven't got there yet. So the 12,000 in the future, what does that make the 12,000? Yeah, right. A. Is that good? Everybody see that? So A is always the future amount, and P is the present value for the deposit now. The R is the 9%. The N is the. Yeah, what is N? 2. We're good with that because semi-annually means N is 2. And the T, 5. 5 years from now. You can see it in between my writing there. 5 years. Okay, so there's the formula. So it's the same thing as last time, huh? We just have to divide by all of that. I'm just going to make this 10 up here. So divide, not by P, but by the 1 plus 0.09 over 2 to the 10. 1 plus 0.09 over 2 to the 10. Boom, like that. 12,000 divided by 7727.13. You getting that answer okay? So it makes sense, doesn't it, that it would be some answer lower than 12,000 because the 7,000 number grows to become 12,000, right? So it's just good to double check, at least to that level. You know, it's easy to hit a wrong button, accidentally get a higher number, then you go, oh, no, it can't be higher. It's got to be lower. You know, just catch your mistakes. On a test, remember, I really suggest run the numbers twice because it's so easy to hit the wrong button on the calculator. Just do them twice, get the same answer twice, you're good. If you have time for all that, I know tests can be time pressure. Questions on that? That good? All right. Okay, number 15. As the prize in the contest, you're offered $29,000 now, or $43,800 in 7 years. Yeah, you hear about these kind of things. So, like, what, you know, a certain amount of money now or a certain amount of money later. How do you? It's kind of like the time value of money. So, so the whole trick is, you know, what could you invest it in, and that's, I don't know, that's hard to always tell. So which is better, basically? If you win some prize, they say we'll give you $29,000 right now, or we'll give you $43,800 in 7 years. Which one's better? So basically, what we have to do is figure out if we took our $29,000 and invested it at 5%, would it grow to be bigger in 7 years than the $43,800 or not? That's all they want us to do. Is just basically see which way would be more. So same formula, A equals P, 1 plus R over N to the NT. And the P, the principal, is the 29,000. So we're just going to basically say, let's put that 29,000 in an investment for 7 years. The interest rate is 5%. What's the N on this one? It's compounded annually, so N's just going to be 1 on that, right? 1 time a year. And the T is 7 years. So yeah, try that. Hit the buttons on your calculator. I'm getting 40,805.91. You guys getting that? So looks like the 43,000 is better, huh? If you don't need the money in the next 7 years, I guess, huh? It's always the time thing. My sweet wife and I always have these discussions about investments in the future, and after all these years of 25 years of marriage, and I don't know if this always happens in marriages, but one person tends to be the long run person, and the other more. Really, my wife's a little more balanced. I'm always like, yeah, but let's just pay more on the house here, and then let's do this there, and then in 20 years we'll just My wife's like, we got like 5 kids right now in college and weddings coming up probably. We're not going to survive 20 years if we put all that money. And I'm like, yeah, okay, you're right. I'm a little crazy. I'm always saying, yeah, but down the line, we have to live today as well. Anyway, all right, so there we go. So if this had come out higher than the 43,000, then we would have chosen that, right? It's just whichever one's higher there. All right. Bank One offered an 18-year certificate of deposit at 4.75% interest compounded quarterly on the same day on the internet. First Bank offered 18-year CD at 4.7% compounded monthly. See it's different compounding times, quarterly, monthly, and the rates are really close. Find the APY, the annual percentage yield for each, which is actually better. So, like I said, there's another APY question coming down the line. So here we are. So so the whole key is it's APY. And do you remember what we do? We put in $1 for 1 year, because that's what annual percentage yield means. It means annual 1 year, what's going to be yielding. So put in $1 for 1 year, then subtract out your original dollar and turn into a percentage. So there's how we do annual percentage yield again. So do that for both of these accounts to see what they really yield. So in other words, one of the banks is claiming, well, it's truthfully saying, it'll pay 4.75% quarterly. The other is paying a little less, real close, 4.74, but it's compounding more frequently. It's paying you interest more frequently. So it's gonna be a little higher. They're both gonna come out higher than they are listed because we're trying to find out what happens in 1 year. They're both compounding more frequently than once a year. So really they'll give you a little more than that once a year. Figure out the annual percentage yield for both of them. So let's do it for the first one, for the 4.74% quarterly. So for that one, so again it's P1 plus R over N to the NT.
4.74 is monthly.
Oh, you're right. I meant to do the 5. Thank you for stopping me before I did the whole thing wrong. Let's do that. Yeah, I meant to do the 5 one first. You can do either order, doesn't matter. So $1, put in principal of $1. It's always how we do APY, annual percentage yield. Put in $1, 1 year, 4.7. Oh, I'm supposed to turn that into a decimal, huh? 0.0475 over N. Now, what is N for the quarterly? N is 4, compounding is a year. To the 4, and T is, we're just doing 1 year. So everybody good with that? So again, I just put in $1, 1 year. And hit the buttons on your calculator. I'm getting 1.048, 3528. m21-5.2. Supposed to subtract out the original dollar, 0.048352, and then change to a decimal, a percentage, 4.84, I guess it would round to, huh? Oh, it says 3. Type round to 3 decimal places. Okay, I didn't read the words there. So let me do a little better. Right here, right, it says round to 3 decimal places. 3.5. So 4.835. 4.835, yeah, is that one. So there's that one. The other one then, I'm going to erase this if I can and do it over here. So the other one is P1 plus R over N to the NT. So this will be the, 4.74% monthly. So, again, $1 for 1 year, 0.0474 over, and, it's supposed to be 12, huh? N is 12 for monthly, so I should have made that 12 for 1 year. So again, $1 1 year, that's how we always do annual percentage yield, what happens in 1 year annually. To $1. If you find what happens to $1, you know it's happening to all the dollars. All right, type that into your calculator. You guys are already done and waiting for me, huh? Okay, divided by 12 to the power 12. So I'm getting what you got probably 0.48444344. Get that. So then subtract out the original dollar. So we just get the yield. Move the decimal 2 places. We get the percentage yield, 4.844%. 4.84. They wanted 3 decimal places. All right. So which one's better? This one, huh? So the 4.74 monthly actually ends up. And so what that means, what these numbers mean, is that 4.74% done monthly, really, in the effect, the actual result, is you'll get 4.844% of your money every year. That's what we're finding. We're finding what really happens after a year. 4.844%, and on the other one, the 4.75 quarterly, the real result after a year will be 4.835. So the monthly one's doing a little better every year. They're pretty close. That's a little better. Does that make sense about annual percentage yield? It just shows you what really happens in a year. Again, they have to put this on loans and things like that to let you know really what happens in a year. Questions? Can I flash off of that? Good. Okay, so annual inflation 7.5%. How long will it take for all the prices to double? So if inflation is 7.5%, how long will it take for all the prices in the economy to double? That's basically, inflation is basically compound interest. It's the same thing. So we just use the same formula. A equals P, 1 plus R over N to the NT. Same formula. But here's the deal. So when they, here's what I'm going to suggest. Let P equals $1 and A equals $2. Well, yeah, all right. There's all kinds of ways. You could just let the A be 2P, and that would work fine also. It might be easier for you just to say, hey, if I'm wanting prices to double, I'm wanting to know how long until $1 becomes $2. Or you could do $2 becomes $4 or $3 becomes $6. It'll work the same. You can pick any pick any number you want for the principal investment and twice that much for the amount it becomes, and this formula will work. Does that make sense? You're just saying I want all prices to double, basically. So do that, and so I'll just make the A be 2 and the P be 1, and then the interest rate is 0.07. The interest rate is the inflation rate, because that's what inflation does is makes things grow like that. And N is the number of compoundings per year. That's just one. It's annual, right? Annual N is just one. And the T is what we're looking for, huh? Because they said how long, how many years. So I want to find out how many years. So if the economy grows by inflation if inflation causes prices to grow at 7.5% per year, how many years until everything's double the cost they were? So we have to solve that formula for T. You guys with me? So go ahead, I'll let you guys do that. Solve that formula for T. Anybody know how to do that? It's a hard one. It's a real hard one. Like, how can we solve that for T? We can't just divide, we can't just go divide by the 1.07, because that's not times T, it's to the T power. See the difference?
Can you use natural log?
Yeah, good job. Yeah, everybody first see why you can't just divide, because if that T was on the base level, just multiplied right there, then yeah, we could just divide. That's what we did on some of the other ones. Yeah, good thinking, guys. We can just divide, or you can use your graphing calculator. That's fine with me. I mean, if you want to graph, let this be y1. Whoops, not right in there. Let this be y1 and let this whole side be y2, and just see where they intersect on your calculator. That's fine too. I'll show you the math steps for natural log. Yeah, good memory. How you guys remember that? I'm impressed. Yeah, that's when the letter's in the power zone. Natural log will take care of it for you. Let me go to a new screen and try to memorize that. Okay, 2 equals. Yeah, so 2 equals 1 plus 0.075 to the T. Yeah, letter in power, you're totally right. Natural log both sides, that's right. So, good. So, natural log this side, natural log that side. And 1 plus 0.075 is just 1.075, right? Oh, and that 1 times, can I just get rid of that? 1 times anything is just itself. That's not doing anything, right? Okay, I clean it up that way a little bit like that. And now, remember the T can come to the front. Remember, that's the great quality of natural logs. They let powers come down to the front like that. So then you get natural log of 2 is T, natural log of 1.075. And now that the T has come from the power down to the front, now you can just divide. You see, because the T's not in power anymore. That's what's so difficult, is when that T's up there in the power zone. So yes, and now we can just divide by the natural log of 1.075 on both sides. Like that. Hit the buttons on our calculator. I'm getting 9.58. I don't know how far they want me to round. What did they say? Round is whole number. Okay, 10 years, huh? About 10 years at that inflation rate for prices to double. You guys able to get that? Not making sense. So it's hard to remember to do that, huh? You might want to write a note on your 3x5 chart. When the letter's in the power zone, that's when you do natural log of both sides, because that makes powers come down to the front, and then it's much easier to deal with. You just divide on that. Or you can do it on your graphing calculator, like I said, y1, y2, graph it on the screen, do the intersection routine, and find out where they intersect. You should get the 9.58 answer as well. All right, we can't throw away these 10 minutes. We need to tables. What tables?
For future annuities for present value.
You mean like where do you have tables?
We're not using table, we're not doing future value.
Yeah, I know they have tables. We won't be. We'll just use our calculator in this big old formula. So Find the future value of the following ordinary annuities. Payments are made and interest is compounded as given. So what are we talking about? What an annuity is when you make a bunch of little payments, payment, and the thing grows and grows until a big pile eventually. That's an annuity. So that's like paying off your house, right? You pay and pay and pay and pay and pay and pay and pay until you paid off this big old thing, right? So that's an annuity. Or if like you're storing up money for retirement, or for a and actually, you know what? Let me take back what I said. Buying your house is actually the other kind. What we'll do next week. This is like saving up for retirement. That's correct. Or vacation or something. You know, you save for 20, 30 years, 40 years for retirement. You just keep putting money in the bank, and when you retire, you got a big old pile to live off of. That's an annuity. Just if you set up regular payments from your bank account for vacation or for college or for buying a car or for retiring or whatever. Those are all an annuity. So what an annuity is regular payments. So regular payments into an account. So regular payments into an account that grows with interest to a large pile over time. So that's the idea, if you can read my scribbles there. So an annuity is regular, that's supposed to be regular payments into an account that grows with interest to a large pile over time. So that's different than what we were just doing, compound interest. Everybody see the difference? Compound interest, the section we just finished, you put the money in the bank one time, like the person gave him $9,000 at birth, right? And that $9,000 alone grew to become whatever it was at the end, $36,000 or something, at the end of 20 years. That's just one-time payment, grows over time. Whereas an annuity, you're making regular payments into the account, and they're all growing as well. See the difference? So an annuity is regular payments. Compound interest is just a one-time, and then it grows for lots and lots of years. So an annuity, regular payments into an account, like saving up for retirement. So we got a big old formula. Let me give you the big old formula for it. It is S equals R, 1 plus R over N to the NT over R over N. It's kind of a big messy formula. And now, Math Excel has the following. They simplify it a little bit, but I found that's hard for students. They do this. That's the same formula. They're just letting the I be R over N. Well, and they're calling this N something a little different than what I'm calling N. So I just want you to know, if you click on the help buttons, you'll get a little different formula. I don't want you to be thrown off. I think you'll have an easier time using this one because everything is shown on it. And it'll be consistent also with the formulas we just used in the last section. Whereas if Math Excel kind of changes the game a little bit. All right, so with that said, it's probably, if you didn't get that down, you can get it next time. I'll write it again. So, well, actually, I need to write it again right now. So let's do at least one of these before we break. So let's do this one. Whoops, I'm doing Math Excel's way. R over N to the NT minus 1 over R over N. Okay, so there we go. So this, now the R means the regular payments. Regular payments. The S stands for the sum at the end. Honestly, I don't know what S and R stand for. I'm kind of making this up as I go along. All I know is S is the amount at the end. So I'm saying sum, I guess. I don't know why they use S. Just add them all up. And the R is the regular payment. So that's what they are. So all right, so let's give it a try. They're telling us the R is the 4,000. And the interest rate is 10%. The N, what is the N on this one? Where does it say anything? Where does it say it?
Annually. Compound annually.
Oh, yeah. I put my arrow over it. Yeah. Thank you, right. Compound annually. So N is just 1, yeah. And 5 years, yeah. Over R. Yeah, like that. And then you just hit the buttons on your calculator. If you can type all that in. You know, let me help with that. What do we got, 3 minutes? It might be easier, especially with the graphing calculators or any calculator that has an answer button, to just start right here, actually. Rather than like trying to type the whole thing in all perfect and everything, just kind of start from the inside and just go 1 plus 0.10 over 1, hit equals, and then go to the power of 5 equals, minus 1 equals, divided by that denominator equals, times 4,000 in the front equals. Does that make sense? Kind of work your way through it that way. I think it might be easier. I'm getting 24,420. My pen just ran out. I got to buy a new charger for this pen. But anyway, 24,420.40. Written with my finger. Is that what you guys are getting? So what that means is if you make $4,000 payments into an account every year, once a year, for 5 years at 10% interest, you'll have at the end 24,420. All right. Well, we're not gonna get any more done. So why don't we stop there on that?